Hello and thank you for listening in to this presentation today. My name is Chris Moore and I'm a director in the Advanced Analytics team here at Ipsos Mori. I'm going to talk today about a method called menu-based choice, which is one of a number of variants of a larger field called conjoint analysis. Don't have time to go into detail about the power of conjoint in this talk, but in essence, conjoint allows us to elicit importance of different elements that compose a product or service. By understanding what's important, we can then simulate different product configurations in near market conditions to identify optimal solutions. In this talk, I'm first going to give an introduction as to what menu-based choice is. I'm going to show an example of it working in the restaurant industry where we validated the findings with real-world data. And finally, going to give some tips for conducting menu-based choice experiments because the cost and time can vary depending on how you ask respondents the exercise. Now we know that making decisions can be complex. When you walk into a shop, there are many products, all at different price points. Some are on promotion, some are not. So how do we determine what customers really want? And more importantly for our clients, how do we determine what set of prices we need to offer to maximize some financial KPI? We have this example menu here. We know there's going to be interactions between items. So if we change the price of the meal deal, that's going to have an inherent effect on whether people actually choose the a la carte options. Now, there's a number of ways in which we could go about answering this problem. The first is through direct questioning. We could maybe look at each of the items individually and ask for propensity to buy, but we have the issue here that we're not getting the interactions between the food items, which we know exist. Another option is that we could scrape data from website forums and just understand what people are talking about. Do they feel that some items are too expensive or too cheap, for example? Our clients could look at competitors and react to competitor pricing in order to keep the status quo. More often than not, what they might do is change their pricing and after 3 or 4 weeks, get the data and try to do some modeling to isolate the effect of that price change on some key metrics. But a common research way to look at this problem is through a method called conjoint analysis. And this is an example of what you might see if conducting a traditional conjoint. Here we present respondents with different scenarios which contain fixed solutions or fixed options, and we ask respondents which one they would prefer and at what price. And this is repeated a dozen or so times where the options might be different and the prices are different also. And we're just trying to elicit what people prefer under different pricing conditions. And from capturing this data, we can simulate what people would actually choose for any given combination, even though we've not directly tested it. But there are some issues. We're typically limiting respondents to a single individual choice. And more importantly, we're not allowing the consumer to configure their own product. We're giving them forced products or fixed products. But this build your own BYO concept is extremely important when we're trying to capture the market dynamics where there's lots of products and features available. Now, there's many situations where consumers can pick their own product, and it's certainly gathering pace in the last decade. We've given examples of retail, so coffee, restaurant shops, fast food shops. Telecoms is another big area where you might buy a SIM-only contract and then have data bundle add-ons. It's very prevalent in business. If you're buying insurance, you might buy bolt-ons for legal insurance. Large businesses are offering software suites, so you can buy the entire suite of packages, or you can buy individual a la carte options. And through to conferences and training courses that are being offered, you might only pay for day 1 rather than paying for day 2 and day 3. Transport is another big area. This is one of a typical area where you would actually have to buy a base product first, and then you can buy add-ons to make your product more desirable. Similarly with accommodation, again, you can buy a base accommodation, then add dining packages or cleaning packages on top of that. And media entertainment is a very popular one where you might be trading off between TV, broadband, and phone add-ons, and subscription video on demand elements like Netflix. You can have different options depending on how many devices you want to be able to screen on. So why menu-based choice? Well, in essence, these exercises allow us to simultaneously measure multiple correlated decisions in situations where the consumer can create their own product bundle. And there are many benefits of menu-based choice. It's a very realistic environment where we actually get people to build their own configuration rather than forcing a choice on them. We can actually get price demand curves for each of the items that we're looking at, so we can get really good pricing information, and we can get realistic financial KPIs, because not only do we understand what people will buy, but how much of each item they will buy. We can also identify items that cannibalize each other through the analysis, and similarly, we can also understand which items consumers are picking together, as that might help the client build additional bundles. So we get all the benefits of traditional conjoint models, but now we can really model this real world complexity of actual decision making. So in an example, this was a menu-based choice we did for a sports company. They traditionally only had a multi-sport pass option available. They wanted to understand if they offered individual sport passes, whether there would be increased take-up on their platform. In this particular example, respondents could choose either from the multi-sport pass or the individual sports passes. If they chose a multi-sport pass, then they could choose either the standard or the premium. If they chose the standard, then they could choose from additional add-ons, which are all already available in the premium. Then they could also choose between the monthly pass and the annual pass. So they have completely free reign over what bundle they want to purchase. I won't go into detail about the analytics behind menu-based choice, but just to say that one of the typical methods for creating this is something called the serial cross-effect model. So this is where MBC and traditional conjoint diverge, because within traditional conjoint, you will only ever create one conjoint model, whereas within MBC, what you'll do is typically create a model for each item that you're testing. So in this example, we have 5 items, and respondents could select from 0 to all of the items. And in the modeling process, or this cross-effect process, the desirability or utility for item A is not only a function of its own features, so the inherent desirability of the item plus its own price, but we can also include these cross-effects of pricing from the other items within the design. And this is where, like I said, it differs from traditional conjoint, where the desirability or utility of a product is solely a function of its own items. Going to go through a case study now that we did for TGI Fridays some years back. The main objective was to understand whether changing their headline price for their 2-course meal would have a big effect on whether people come into their restaurant or not. And for those that come into the restaurant, how much switching behavior there would be, and are they moving to higher or lower margin products, which then will enable us to understand revenue and potential increases in revenue and profit for TGI Friday. Study details: it was a UK-only study with around 1,500 respondents, all under 35 at a particular life stage, and they were screened on whether they ate out monthly or more in branded restaurants that served alcoholic drinks and offered full table service. And it was important that they had a TGI Fridays in their area, and the area was defined as where they lived or where they worked. In terms of the design, we agreed on a subset of the full menu. So we had 5 starters, the 2 bundled offers, 10 main courses, 6 desserts, and 5 drinks. So while this menu is much smaller than the actual TGI Friday menu, it actually accounted for around 70% of all the items purchased in a standard TGI Friday restaurant. Questionnaire flow, to start with, very standard. So a lot of U&A demographic screening questions. We also asked about their most recent dining occasion, and this is very important for the exercise because we need to put people in a particular context. If we don't give people a context, their decision-making processes will be completely different to whether, whether they're eating in, whether they're eating out, whether they're having a romantic meal for two, or whether they're having a birthday party. We then conducted a choice-based conjoint where we tried to understand movement in and out of TGI Fridays as the pricing changed. So this was in a competitive context, and we wanted to see whether when we changed prices, would people switch in and out of TGI Fridays. And the second stage was the actual menu-based conjoint itself, where we showed the restaurant menu for TGI Fridays, and under different pricing scenarios, we asked them what they would purchase on that occasion. Just to show that visually for those two stages. So in this stage, the respondent had a Harvester and Pizza Express in their area. They chose the Harvester as their preferred competitor menu. This was then traded off in a choice-based conjoint against the TGI Friday menu, where only the pricing of the TGI Friday menu changed. Then in the second stage, they went through the menu-based choice, where they selected the items that they wanted. We imposed a number of limitations on the design. The first is that we split the main menu into smaller areas. So it very nicely fits here, appetizers, main courses, take twos. And by doing this, we really reduced the burden on the amount of modeling that we need to do. By doing this, we only had to create 5 conjoint models, one for each of the 5 areas, because there's only one choice being made. If we allowed, for example, people to choose multiple starters, then rather than having to build one conjoint model, we now have to build 5 conjoint models. So that's a limitation that we try to put into our designs where we can. We also said respondents couldn't select the same dish multiple times. This lends itself to volumetric menu-based choice, and again, the layer of complexity is significant for the very few % of people that might do that. Then there were just some standard limitations. If someone picked one of the take two meals, then they couldn't pick from the a la carte options, and vice versa. And on some days, the take two options are not available. So depending on what someone said their last occasion was, we either had the take two options available or not. From that data, we could then create some simulation tools to model what would happen under different pricing scenarios. So from the first stage, we can actually model share going in and out of TGI Fridays. We knew the base case pricing. So if this was the base case pricing, then TGI Fridays would get 32% share. And then as we change pricing, that figure would change. And then we could convert that into a percentage increase in terms of the number of covers, or decrease in terms of the number of covers going into the restaurant for different pricing scenarios. Then in the second stage, from the menu-based choice, what we can see is understand what items are being chosen. We can see here that around 35% of people are choosing a starter, only 13-14% of people are choosing a meal deal, the rest choosing an a la carte main course, and only around 15% choosing a dessert. And from this, we can change the pricing of the individual items, and it will change the share of choice for that item and a number of the other items, because we've modeled the interaction terms between the items on the menu. We need to get some semblance of profit, then we can do that because we have all the individual components. From stage 1, we could determine the change in the number of monthly covers. From stage 2, we could determine the volume of each dish, and therefore the basket size or checkout size of what they were buying. And the client provides us with lots of data in terms of fixed and variable costs, including the cost to make each of the meals, so we can understand profit. From that, we use this software called Oracle Crystal Ball, which is like a genetic algorithm. And what we could do is then use that to understand what the optimum set of pricing was across the entire menu. What the client did is they took the recommended menu and put it in about 10% of their stores, restaurants. And then they gave us data after 3 months for those 10% of restaurants, as well as the 90% that had the original menu. menu. And they also gave us data from the same period 12 months before. And once we looked at the data, we actually saw that profit increased 31% in the restaurants where we had the recommended menu-based choice menu, and that only compared to 12% increase for where the restaurant hadn't used the new recommended menu. So this is a very real-world example of the menu-based choice working and working well. Just going to finish the talk by giving some tips for conducting menu-based choice. I hopefully conveyed that menu-based choice projects are much more complex than standard traditional conjoint models, and they can become even more complex and even more expensive very quickly. So the key word here is be pragmatic. You saw in our example, we only allowed people to pick one appetizer. Yes, people do pick multiple appetizers sometimes, but for the additional complexity and for the very few people that actually do that, do you want to have that extra layer of complexity? You know, in some projects you might have to because the number of people doing that is significant, but in our case, or in this particular case, that wasn't likely to happen. One for the analysts, but most of the academic research in this area shows that simpler models work better. And by simpler models, we mean don't include all the interaction terms that are available, only include the ones that are significant. It does mean that as you change the price of an item, it only affects the share of a subset of the other items, but the studies are showing that this provides much more detailed and accurate data than just throwing everything in there, because that just creates a lot of noise. We also recommend to include what we call holdout tasks in your experiment. So these are tasks which is identical, and every respondent has seen that specific task, which means that we know what people have actually said to that scenario, and then we can model that scenario and we can look at the differences. And by including that holdout task, you can then play around with your models to see what interaction terms allow your model to be more accurate and which ones are having less of an effect. A key element here is that if you are doing some sort of optimization analysis, don't rely on the non-option. It's typical that in any conjoint you have a non-option, so you allow people to not select anything and say, I would not choose it. And that's to mimic people walking away, for example. But in survey research, respondents don't use that as much as they would do in the real world, because they're actually trying to help us by answering the surveys and they're giving their preferences. So if you only rely on the non-option, what will happen is that your optimum solution will be everything at the highest price, because you don't see that flux of people moving away from the product or the restaurant. So you need to include some additional purchase intent questions on top of this. And so you might, after each task, just ask their likelihood to actually buy the product or go to the restaurant given that set of pricing. Because of all these interaction terms, menu-based choice is very data hungry. So in order to model these cross effects, we always recommend at least 500 as a good starting point. It does obviously depend on how many items you're testing. If you're only testing 4 or 5 items, then you might be able to get away with a smaller number, but typically these restaurant menus and just general menus might have 20 or 30 items. So you really want to be looking in the thousands in terms of sample size. I mentioned previously that context is extremely important. So what is the occasion that you're asking people to think about? Are the different menus by time? If McDonald's have a breakfast menu and a main day menu, if people only go into breakfast time, then why are you showing them a main day menu? Are people eating in or taking out? Who are they with? What is that? What is the specific occasion? Is it a romantic meal? Is it a birthday party? All these will affect the decision-making process of the person. We also recommend that people only talk about what they would do and not what other people in their party would do, because you can't answer for other people and what they would do. And finally, just don't underestimate the time needed in the setup phase. It's a very iterative process. It's new to a lot of clients, and it can take quite a bit of time to set up. Finally, here are just some references of papers that you might want to read on menu-based choice. A lot of these can be found on the Sawtooth Software website, and I'd also like to recognize Sawtooth for this, because I conducted part of this talk with Aaron Hill at a previous conference. And thank you for listening today, and happy to take any questions.